Hey, welcome everybody. Welcome to all of you to in this segment. So, in this video segment, basically what we will see. So, in this video segment, basically we will see that is the microcontroller introduction and our field of interest of the microcontroller is STM32F1 series. With you, I'm again Mr. Rimon from United International University, Bangladesh. So before knowing what is microcontroller, we need to understand what is the opposite of a microcontroller. So this is the opposite of the microcontroller and microprocessor is the opposite of microcontroller. Microprocessor is general purpose computer like daily we will use a laptop, desktop, etc. Basically, we use computers. We listen to music, we play games on it, we watch videos. By using computer, we do editing and by using computer, we do browsing also. So this is the microprocessor and this is Intel microprocessor Core i7 and if we look at our computer motherboard, we can see that the computer, the CPU sits alone somewhere on the motherboard. All the other devices that will be connected with the CPU are connected here in the form of slots like RAM, ROM, hard disks, and some input-output port. All right. So what I mean by this is that the devices connected to the CPU are connected to the same board but distributed in different sites like these. So there is no specific place together actually. They are unintegrated. This is the processor that is fine, that's good, but they are actually connected on a same motherboard and internally they are connected with the PCB layer. This is the system bus and other devices say clock, RAM, data storage, and the peripheral devices. Actually, they are unintegrated, but they are placed on the same board, but unintegrated. So basically, this is what we actually think of as a microprocessor. And the derivative of the microprocessor is actually microcontroller. So this is the derivative of the microprocessor, which is called the microcontroller. So this is our microcontroller. This whole thing is actually called the microcontroller. But the question is that what is the microcontroller? A microcontroller is an integrated circuit that is programmed to do a specific task. Microcontrollers are really just a mini computer. It's a miniature version of our laptop, desktop, laptop, etc. If we want to automate a specific task over and over, again, we often want a job to be perfect, be edited again and again. Then what is important for us is that we have to use control mechanism. The fun part is that we do all these control things with this microcontroller are very nice, and we can do this exactly what it looks like. It can be some kind of magic. Actually, it's not a magic. Actually, we program the microcontroller in such a way that it can do what we actually want. So the basic distinguish between the microcontroller and the microprocessor is very straightforward and very simple. That is, the microcontroller is integrated in a single chip, in a single chip. And inside this chip, we have the microprocessor and other communicate related networks such as system bus, clock bus, RAM, data storage, peripheral bus, etc. So it's a single chip. The microprocessor is unintegrated and it's not a single chip. So this is the basic distinguishing between the microcontroller and the microprocessor. Let's see the difference between these two in the picture. So I think now this is pretty much unstable. Basically, we will learn actually how to program this microcontroller. So that is why the name of the microcontroller we have chosen is this STM32F1 series. So as a microcontroller, it is a very good microcontroller, and our objective is how to work the microcontroller. Actually, this is not our main focus, and the main objective is that how to program this microcontroller. Okay, so let us see the look of the microcontroller. So this is the STM32F1 series microcontroller, and on this board, this is the microcontroller location, and this is the built-in LED on this board of the microcontroller. At the port C, and the pin number is 13. So this is the built-in LED of this particular microcontroller, which is built in on this board and inside the microcontroller connection. All right. So let us looking at this microcontroller from different sides. This is the top side, and this is the bottom side. So let us see the feature of this STM32F1 series microcontroller. So this STM32F1 series microcontroller from STM Electronics, STM32 series, and we are interested for STM32F103C8T6, this model. So it is based on the ARM Cortex M3 core and commonly known as Blue Pill due to its small blue PCB design. So this is known as Blue Pill. Also, this is known as Blue Pill. So the key feature of this microcontroller, number one is the CPU, which is ARM Cortex M3 core running up to 72 megahertz. So I think 72 megahertz, its maximum running clock frequency, and this is good, not bad. This is very good. So inside this have a flash memory. It may be 64 kilobyte or it may be 128 kilobyte of flash memory for program storage. Whenever we program this microcontroller, the programming data, that is the machine language, that is the binary form, it need to be stored in a memory. So that memory capacity is maybe 64 kilobyte or 128 kilobyte. So it have a RAM, that is the random access memory, and it is SRAM, which is a 20 kilobyte of SRAM for data storage. And also it have some GPIO, that means this pins actually. So GPIO means this one. So GPIO means actually, so these are the GPIO. That is the general purpose input output pins. Okay. So these have in total three port. Let's say port A, port B, and port C. So it have some peripherals, various, like whenever we do serial communication, synchronous or asynchronous mode operation. At the time, this will be important. Also, it have timer mode, ADC. This one is built in inside this microcontroller. And also we have PWM mode and a USB slot. So this is the USB slot, and this USB slot is basically micro USB. All right. So we can observe these things. So once we know this general knowledge, we can start programming the microcontroller. But how we can actually program this microcontroller? So number one, we need a programming environment. For this reason, I use here a software that is Cube ID 32. Cube ID 32. So this is actually nothing but a compiler. All right. And second one, we need to test the simulation. For this case, I am using here Proteus 8.15 version. So these are the common software. We need to use this. And the last one, that is the ST-Link. So what is ST-Link? ST-Link is basically very important. Okay, so whenever we compile our program, that at the time we will get some binary value like 001, 001, 001, whatever it may be, right? So we need to upload or download this binary value into our microcontroller. But the problem is that inside the microcontroller, there is no built-in programmer. So there is no built-in programmer. So we need to use an additional device, that is ST-Link, which is actually link the microcontroller program and upload this is into this microcontroller or download this in this microcontroller. So we need this software for that purpose, just for downloading purpose, nothing else. So let's see the scenario. So if I write the code inside this compiler, and then build and run, we get the binary file, and then use this ST-Link. Just we upload our program through this device or this programmer or the dongle, and after that the dongle is uploaded this code on this chip, and then the chip will work. So this is basically the practically whenever we want to implement at that moment that situation may be arise. So this is the dongle connection or the ST-Link dongle connection with this microcontroller. How to we can actually perform this? I'm giving here this explanation, and I think this is very easy to understand. Thanks for watching. The next video I will start the experimental example series chronologically or sequentially, and with this I conclude this segment. Thank you everybody, and assalamu alaikum.